Okay, we are back. Can everyone see my slides?
Hi, Scott. I think you might want to switch screens.
Can everyone see my slides now? How's that?
Much better.
Fantastic. So let's begin. Welcome back. Hopefully everybody who needs the PDH credits has completed the 2 PDH forms, either by using the QR code that Ryan showed during the presentations, and we can do that again at the end. We will show all 3 QR codes at the end, or you can go into the URL that is posted on the bottom right of each of these slides for the decarbonization panel and get your PDH credits finalized. So the decarbonization panel consists of 9-10 members. Matthew Rubenstein is going to join us, David Chen, Douglas Cochran, Don Colliver, Drew Crowley, Richard Gerbe, Charles Marino, Vance Sherpani, Beth Tomlinson, and Paul Torsellini. I am not going to go into everybody's bio to save time so we can get more questions here. And I'm going to put up the first question of what is the difference between building decarbonization and building electrification? And I am going to ask Beth Tomlinson from Stantec to answer that first. Beth, are you with us?
Can you hear me now?
Yes, I can.
Wonderful. Okay. I am going to explain that decarbonization is the reduction of greenhouse gas emissions, and that encompasses both the operations emissions as well as embodied carbon. And so embodied carbon is a larger context of the greenhouse gas emissions associated with the buildings and systems throughout the whole life cycle. And so it can differentiate between operations and the emissions associated there. So building decarbonization is a broader context than fuel source choices. So that is my answer for the difference between these two.
Very nice. And Doug Cochran, are you on the line? Well, if we don't have Doug yet, I am going to ask Van Sherpani.
Well, as you know, regarding again, same thing with the decarbonization. You know, that's the reduction of your carbon footprint. You know, comparing that to electrification, which is electrification is one form of decarbonization, which you know, will apply toward that, you know, entire decarbonization process.
So so electrification really is a subset of decarbonization.
That's correct.
Industrialization is Richard. Richard is a specialist in providing products and systems for 30 years, first with Train, now with his own company, Highmark, that he owns and founded. What are you describing decarbonization and electrification to your clients as?
Well, I agree with both Beth and Vance, but you know, honestly, I think it's so new to the industry, and it's a new way of thinking that I really hear the term being used interchangeably. Because right now, I mean, realistically, we are electrifying buildings. That's the step that we're taking toward decarbonization of buildings in New York. You know, the reality is, as time goes on, I think there's buildings like, you know, 270 Park Avenue, which is kind of an interesting case, right? They're recycling, they're looking at their embodied carbon to the best that they can, recycling concrete, recycling metal from an old building to build a new building. But yeah, I think we're a long way off. We're not making purchasing decisions, equipment decisions. We're not looking at embodied carbon in most of the products that we're using in buildings. So, you know, we hear decarbonization, that's the ultimate goal. But right now it truly is kind of electrification. But again, I hear that term used interchangeably, and I kind of think of, you know, them both one and the same.
Well, that's why I'm asking the question, because they are used interchangeably. It's not tiring, but it's time consuming to discuss the difference with clients, because they kind of have an idea of that. But there's not a lot of publications, and well, there are a lot of publications and articles that I've been seeing, ASHRAE Journal and Consulting Specifying Engineer, and just normal magazines like New York Times and even the New York Post. But it doesn't seem to, the message doesn't seem to be getting to the buildings. Maybe the higher architects, the hierarchy of the buildings, but not the building engineers, the building managers. They're really kind of being left out of the game. It's one of the reasons why I wanted to have such a diverse panel here, not make it just about New York City. You have a lot of people that are responsible for buildings all over the United States and Canada. That's why I have a couple of gentlemen from Canada on the panel and as alternate panels to get a better feel for what's happening across the US. Charlie, what do you see as the issue with the customer not understanding really how to get to local law 97? Are they getting decarbonization?
Yes, I think it's part of the issue we were just talking about with the concepts behind interchangeable thoughts between building decarbonization and electrification. Something we try to remind our clients is that energy efficiency is actually still a cornerstone of the whole discussion, especially for existing fossil fuel-based systems. You want to first reduce consumption as much as possible and then think about electrification. So, when it comes to local law 97 compliance, trying to identify what that roadmap is for each individual building is really key, because they might have different needs based upon what that existing markup looks like.
And Don Colliver, what do you think of where this decarbonization, electrification, communication issue is?
I think you're pointing out something that is significant, but one of the comments that I think that we need to think about is looking at the word decarbonization to begin with. Really, the D or the DE in front of it tells us a lot. And that is that this is a process of trying to reduce carbon usage. Many people think of decarbonization as just taking and totally reducing or going to net zero carbon. And really, it's the process of reducing the carbon in the building, and that's why we have goals of 2030 and 2050. So it is, though, I think, much broader than building electrification, and that electrification is one of those pillars, one of those three pillars of what it takes to decarbonize a building.
Thank you. So the reason why I'm starting off with more kind of a definition and an understanding of these words that we're using is as buildings make decisions, they really have a lot of issues to deal with, especially now that we're post-COVID or we're still locked into a pandemic world, but maybe we're not necessarily thinking we're in a pandemic, where indoor air quality and comfort becomes a major issue to get the tenants back in the commercial buildings, right? That's why residential use is so high right now. So, these terms that are being thrown around, the decision makers really have to have a good understanding. And the next one is adaptation. Adaptation, what does that mean? And, of course it means to adapt, but is that, when we talk about adaptation, maybe you could start us off, Doug Cochran. Could you explain adaptation and how it differs or where it falls into decarbonization? Doug, are you muted? We're going to give you a moment, and we're going to go back to Beth Tomlinson. Beth is an integral member of the Building Decarbonization Task Force for ASHRAE. She is also a champion of being the leader of writing the first chapter of the climate change, the Fundamentals Handbook in 2021, which was done in less than a year, which was quite a historical record for ASHRAE. So Beth, what is your description of adaptation? How do we use it to discuss decarbonization?
So decarbonization is the elimination of greenhouse gas emissions, and that's climate change mitigation. And decarbonization is deeply critical to mitigating the worst of climate change impacts to the built environment. But the built environment already has been impacted by current and intensifying climate change. So climate adaptation is designing or modifying the built environment to recover from climate change repercussions. The goal is to improve recovery from adverse events like natural disasters, which we call climate shock, or increasing climate changes like rising temperature or humidity levels, and we call those climate stressors. And climate change mitigation and adaptation can and should be able to find co-benefits. They don't necessarily need to be in different silos. So an example would be a win-win scenario where you improve building performance. So improving building performance or reducing energy consumption mitigates climate change, and it also reduces your reliance on emergency power backup during outages. So that's an example of finding win-wins between adaptation and decarbonization.
So by mitigating and lowering your energy use, obviously you're making your building adapt to a lower energy need and environment. Less source fuel, less renewable power to build. So adaptation and mitigation aren't separate entities. They can be strategically linked. That's what I hear. Hey Vance, do any of your New York City clients ask you about adaptation?
Well, you know, it comes up as a point of discussion when they're initially designing buildings now at the higher level, where they consider, you know, possible architectural impacts that would, you know, allow for, you know, heat pump use per floor basis, allow for, you know, some kind of an infrastructure to carry, you know, condensation for the heat pump PTAC units that there, because, you know, there's that level of conversation now where they're considering that level of anticipation, you know, of the infrastructure to carry the new equipment that's coming out, you know, as they consider things like, well, do we have a central hot water heater for the building system, since everything is going to be heat pump and tenants will control heating and cooling themselves, or do we let the tenant provide their own individual hot water heater just for their commercial use? It may be more effective to do that and not make it part of the infrastructure that then needs to be supported by the building. So it's, you know, there's a lot of that level of conversation. But at the end, when we do see the construction come out and the buildings being designed, I don't see a lot of that being incorporated into the new design. So, you know, we wonder when Local Law 97 will impact the design team enough that they'll actually make these design changes and make that part of the infrastructure so that it'll support more electrical power, more, you know, electric-driven electrification of the equipment, heat pump technology, even electricity for heat pump hot water, you know, any of that, you know, it's that's the kind of stuff we see that we worry that it's not going to be part of the design, the adapted and, you know, mitigation strategy. It doesn't come into play, you know, so that's why we see decarbonization, electrification a lot, like you say, but, you know, this adaptation and mitigation, we're like, we watch it happen very slowly.
Thank you. Don, you mentioned all those guides earlier in your presentation. Are they looking into adaptation to combine and have the audience understand the real need to design, not just for current mitigation reasons and moving away from carbon sources, but to adapt to the changing climate, shifting climate?
Well, that's an interesting question, and there is some discussion about that, and I believe that they're very much still in the development stages, and it's my impression that that is going to be considered. I can't definitively say that we're going to be looking at those issues specifically because, of course, they're still under investigation or still being developed. That is one of the discussions or one of the thoughts that is being put in the work statements, however.
It's interesting. Yeah, that seems to be, it seems to me that right now mitigation and sustainability are the major players, and adaptation or / resilience seem to be taking a back seat. Paul, is that a good definition, a good analysis where mitigation is sustainability and adaptation is resilience?
Let me think about that, and you might want to put the next question up on the screen too. So my thinking of this is I prefer to put all these pieces together, right? I mean, it kind of was mentioned before that if you design a building that has a really good envelope, then that makes it less susceptible to even, hot extremes or cold extremes, from that kind of adaptation. It also makes it less vulnerable to utility grid failures, at least from a asset point of view. So I know that we've done some studies, especially in the residential sector, that looks at very well insulated buildings, even moving to passive solar, and these buildings will never freeze, right? Well, that has a huge value to that homeowner, to the insurance, organizations, et cetera, versus say what happened in Texas, right? Where it got cold and, hot water pipes froze because they didn't know that they needed to insulate them or put them far below the ground, right? And so thinking through those things from an energy efficiency point of view often helps the resilience of the building, it helps the adaptation of the building, and those things start to come together. Unfortunately, when you talk about resilience, most people say, oh, that just means putting in a second fuel source and some kind of generator system, right? But even looking at that, to couple that generator system with a battery system and some storage, or even thermal storage, enables you to significantly downsize that generator system and better use that battery system. And then you can use that battery system all the time. So now we've got this situation where you install a generator, and the thought is we hope to never have to use it, right? And it's like, well, you've just put a lot of money investment in an asset that you're never going to use. Why not shift some of that money into batteries or renewables on site that then can help you all the time and not just when there's a crisis, right? And I think that is some of where trying to put all these pieces together becomes really important. And the boundaries, I know, Scott, you started the question like, does this define this, define this? I think we need to think about these more holistically as all kind of meshing together and the boundaries becoming less clear at the end of the day to solve a common set of problems.
Right. Well, I would surely agree wholeheartedly. It's my belief when we design a building or design a community, as you mentioned, we should be really starting on the base load. I read a really interesting article this weekend about a town in Spain, second largest city in Spain, and they adapted their energy storage from old mines, and they built an extremely robust renewable energy system that could power pumps to pump collected water up the shafts to a basin, a dammed area. Of course, they had to move some people. So that was a major environmental issue. And there's, of course, always environmental issues when you build dams. But then at night, they would let the water run through the shafts at very steep angles into turbines that were seeing something like 42,000 gallons of water a minute. And they were producing electricity for that base load by that renewable power that pumped that water up during the day. And to me, I just, well, you know, you're going to have to figure out where to get these high mountains next to your facilities. But there's mountains all over the place. I doubt these kinds of projects have been together. Is Europe just ahead of the US in adaptation strategies? Beth, can you answer to that? I think your
question is whether or not Europe is more advanced than North America in terms of adaptation measures. I would say that adaptation is a consideration for everyone everywhere, whether or not policies are in place. Yes, I think most countries outside of the US are further along in adaptation simply because they provide projected climatic data for analysis and building design. How that's applied to the industry at large supports, you know, adaptation. So outside of the US, we have projected climatic data in the UK and Canada and Australia and other countries. So I feel like they are analyzing the risk more than we are in the US.
I would like to mention
Scott,
that.
if I could just add.
Oh, go ahead. Go ahead.
Yeah, sorry, Matt. You know, just to piggyback on what Paul had mentioned earlier, you know, we're seeing some healthcare facilities today starting to contemplate that strategy where they have generator systems and how they can maximize usage with also batteries in for the long term as part of the decarbonization strategy. And one of the reasons why our chapter is starting to focus more on the healthcare space with decarbonization. So yeah, really interesting to see some of those concepts for adaptation starting to take place in the industry.
Don, let's let Don first.
Well, I want to address your comment about the pump storage, where you're taking water back up. Tennessee Valley Authority actually has a very large pump storage system. Basically, what it is they have a strong nuclear generation, and you don't turn nuclear reactors on and off. Basically, it's base load. And so what happens is at nighttime, when the demand is not very large, what they will do is they will take a turbine and pump water up to, it's about 1,000 feet. And then during peak demand, they can turn it back on. Just to put it in perspective, the water flows here are in the neighborhood of filling a Olympic-sized swimming pool in a couple of seconds. We're talking about several 100 megawatts. So pump storage is being used in America, and it has been used. This system's been up. I took my class to it 5 or 6 years ago, and it's a fairly old pump storage facility. So we do have pump storage, and it's very efficient and used in the U.S. still.
And indeed, I was going to mention a pump storage project that was initially proposed right here in the New York metro area about a dozen years ago in an old gypsum mine. You know, they make drywall of that, and they had been for many, many years, more or less adjacent to the Indian Point nuclear power plant. That's right on the Hudson, just the northwest corner of Westchester County. And there is a large quarry below. With a very large, effectively a basin above. And the idea was to provide this as pump storage for surplus renewable power, especially wind, that was now entering the New York grid, and to when that was not being immediately consumed, to pump this water up from the quarry to the upper area. And it was conveniently located right by the enormous grid interconnect for Indian Point. Unfortunately, Indian Point and its immediate adjacency to both a recently active earthquake fault and a new very large spectrum gas line for New England meant that that project did not proceed. But the power plant has now been shut down, and I expect that that will be revisited. Further, the Hudson River itself is a place where there have been pipelines proposed to make a lot of pumped storage for the New York metro area. But as you can see, these are huge projects that are infrastructure for the entire New York metro area. And in the meantime, we have to focus on what we can do and are doing immediately, which is buildings. So this stuff is surrounding us. And I don't know if Europe will remain ahead of New York State anyway for much longer.
Thank you, Matthew. So let's go to question number 4. Did someone have a comment?
Yes, Scott, I just wanted to mention that from Don's comment that New York State does have 1,000 megawatt pump storage up by Albany. Again, kind of tailored originally to the nuclear industry for large scale storage. There's another one in Massachusetts. And there's definitely a lot of thinking on those, on how to change the paradigm a little bit, right? Nuclear was on all the time and you had to be able to ramp it up and down. Well, now we've got solar and wind, which are on part of the time, and being able to shift those pump storage and the thinking of those from nuclear base to renewable base, is being talked about. So, but I did want to mention there is a large scale one in New York State, not far from New York City.
Absolutely. I think it also has to be mentioned, I am not a big fan of nuclear. I know it doesn't produce carbon emissions, like that's awesome. But what do you do with the wasted nuclear fuel? That is kind of an issue. Gets us into that sustainability that you were talking about, Paul. When you use that refillable water glass instead of that plastic cup, it makes a difference. Behavior is really huge. So let's move on to question 4. What do the new proposal changes to local law 97 mean for the building owner operators? So let's go to some New York City folks. Richard, can you tackle that one?
Yeah, absolutely. Short answer, building owners aren't allowed to own, operate, perpetuate inefficient, unregulated buildings any longer, is really what it comes down to. They're judging buildings based on their carbon usage, and, as such, puts an impetus on reducing that.
So it's not going to be like the New York Mets where Steve Cohen just blows past the luxury tax to get another $50 million a year pitcher. None of
you could, right? But operating costs are going to go up. Your asset valuation is going to go down. Look at biggest tech companies in the world. They're taking a lot of office space in New York City. They want to be in Class A office space. There's a and Class A office space isn't just nice lobbies and tall buildings with big windows. It's efficiency as well. And a lot of the people that are coming to work now, people in their 20s and 30s, this is a very big focus for them. This is they want to be working for companies that are good stewards of the earth.
Thank you. What about Vance? What about your existing clientele, major clients? You're a large mechanical contractor. You have very large contracts with customers to maintain their facilities in certain areas. Are they coming to you in a huff and a puff and saying, "What do I do? How do I do it?" Or have they gone to an MEP first?
It's kind of a combination. I see a lot of as they just look over the idea. I mean, I have a lot of experience in trying to bring efficiency into their infrastructure over the years. And the whole group has tried to work upgrades into equipment replacement projects. So when they look at changing out an old centrifugal chiller or an absorber, they look at magnetic bearing compressors. They look at those kind of upgrades to their systems that, switch them from steam to electric, but also give them very high efficiencies on their equipment. So their equipment that in the past may have been underutilized, this new equipment can modulate down to lower usage and give them efficiency that they've never been able to take advantage of before. So, we broach the subject that way as they go to infrastructure changes, replacing boiler systems, replacing, equipment, replacing fan coils, replacing, pumps with VFD driven pumps. Those kind of things are, hand in hand with how we approach normal equipment replacement, just as they come up for replacement. As far as encouraging, let me think, the local law, we're a big maintenance company. So, we encourage not only when they get this equipment, but to maintain it. That almost comes hand in hand with this better equipment, is keeping it running, well. So, but this equipment that we're coming out with now with VFDs is for the most part bulletproof. Keeping coils clean and ventilation systems running, that's great. That'll keep everything running at the highest levels. But these new chillers are very very efficient and very reliable, and I think us pushing that equipment is the best plug we can make as a contractor.
David, is that what you're saying, is more of a push to a very, very high efficiency equipment?
I like to step back, just step away from the operating perspective, but these changes for 97, not even just from an engineering, building operator perspective, but even from a real estate perspective, when they buy a new building, most of them, the really smart real estate investors, they would say, they won't just look at the purchasing price for a property. They will also look at, okay, what would be the future local 97 funds? They include that in their analysis. They look at what's the building operating costs, and they include that in their analysis. So I think overall, it's going to change the dynamic how real estate works too, because you might have a relatively, let's say, low cost property, but they're going to look at everything. They're going to look at those annual fines, your operating costs, and that relatively low cost quality may look very expensive, 10 years down the road. So so that's my take on a bigger perspective on what it means for building owners.
All right, so question 5 is up on the board. This is the question or the comment that everybody jumps on me on, all my clients, all my friends, people I meet in the subway, when I talk about decarbonization and the climate crisis and why it's so important. They say, well, we're increasing our electrical use by moving away from highly efficient natural gas equipment. And at the same time, we see reports of all these Teslas on long lines because they don't have enough EV stations. Of course, that's one big push of the IRA package, the Inflation Reduction Act. Supposedly they want 500,000 EV chargers across America, not for public use. That doesn't include the private ones. And everyone just says, Scott, look at Texas. They don't, really see it as, they believe, the people I talk to say, well, Texas is all invested in wind and solar, and they're moving away from coal and gas, and look what it got them. The electric grid just can't handle it. I want everyone's opinion. Let's start with you, Beth. Can the electric grid handle it? What's being done? You're muted.
Okay, so
Yeah.
being from Minneapolis, Minnesota, I can share that one of our concerns is in an extremely cold climate, if we were to transition our heating over to electric, we essentially need to double our electric grid capacity. So there's a significant concern there. However, we can mitigate that concern by improving efficiency. Our building stock can perform better. We can reduce energy demands through deep retrofits, energy efficient strategies. So we don't necessarily need to one-to-one transition to the electric grid. That being said, the consideration about adaptation is also deeply critical. Are the grids preparing for the transition of climate change and the impacts that may occur with extreme temperatures, extreme events, and can they secure performance that we can rely on? So those are two different considerations of whether or not the grid is ready.
Okay, we're going to go for this one in alphabetical order. So Don Colliver, you're next.
This is a very good question, and I'm going to wear a little bit of a different hat if I can, and not the hat of an ASHRAE former president or not the hat of a university professor. One of the things that I had the opportunity to do was serve on a review panel for the Tennessee Valley Authority, one of the largest power providers in the U.S. A review panel and working with them on their integrated resource planning. That is a program where basically they're saying, what should our generation capacity be for the next 30 years? Because it takes a long time to do that. I should say that one of the major things that came out of that is there are several unknowns as they plan for what is their generation and transmission capacity needs. One of those was what is the saturation of the electrical vehicles? Another one was what is the growth of our system going to be? And that has to do with really a lot of economic analysis on what's the economic growth of the several thousand people that are served by the Valley in 10 different states in Southeast US. One of the things that came out of that was, and the development of that was to say, what is our least cost generation capacity based upon reliability and other factors as well. And they had a group of 14, 15 people working on this for quite some time, and we were reviewing it. One of the big unknowns was, yes, we have to provide that reliability, but you have to consider how long it takes to make those investments, how long it takes to actually build facilities. And make a long story short, they came up with our least cost generation and capacity is solar in about 10 to 12 years. You know, we were looking at small modular reactors, nuclear, coal, gas, combined cycle, and the whole bit. And they are going to be putting in about 10 gigawatts of solar in the next 10 years or so. So it is being very much considered. The one of the big unknowns is what is our battery development and the storage of the electricity. And it would have been much more solar, much more wind if we'd known that the battery capacities were going to be increased. But bringing this back to where we are today, I think Beth's comment was, what is the impact of efficiency in reducing what the loads are going to be due to the buildings? And that was one of the considerations that we were talking about when we were doing the IRP. But the amount of efficiency gains that we were looking at was not the value or as good as what we are seeing today with now decarbonization of buildings. So it's a tough question. I know that the electrical utilities are spending millions of dollars trying to answer this question because they are really intent in trying to say, how can we reliably produce electricity and distribute it as it is needed?
Right. Richard?
I hate this question. Because it's meant to undermine, electrification and decarbonization. As it relates to New York City, no one ever asks that question when they take down 10 buildings and replace that with a 1,000 foot tall building, right? No one says, where's the electricity going to come to cool that? Where's the electricity coming to light that, right? So, and I think particular to New York climate, what we see in a lot of instances is your summertime peak and your wintertime peaks of the amount of energy that you're going to use with certain types of equipment are very similar. One thing I've heard a lot of people say in this is, efficiency comes first when decarbonizing or electrifying a building. It has to. It can't be figured as just a fuel switching. Like we're going to come from, like we did with 2 or 4, number 4 oil to number 2 or to natural gas, now gas to electric. We cannot look at it the same way. We really have to fundamentally look at how these buildings are consuming energy and really rethink the way we design these buildings so that they consume less energy, right? That's what's going to make the most effective and successful electrification projects. So, I look at it as, I just fundamentally hate that question, because the other side of it is, you think the electric company is going to run out of electricity? The government's telling us this is happening. We're strengthening our renewables across almost every state. Nationally, it's something that's happening. We'll have the electricity.
Charlie?
Yeah, I also hate that question. So I like how you phrase it, Richard. Within New York City specifically, fortunately, we've had a lot of discussion about this over the past several years. And, I would just reference a really good report that Urban Green Council, the local USGBC chapter, had put together called Grid Ready, which evaluated from a high level what would happen if all the buildings that were currently using fossil fuel for heating and domestic hot water heating had switched to all electric, and kind of looked at the individual grid networks to understand what the impact could be throughout the 5 boroughs. It was pretty interesting. I mean, they were using benchmark data, they weren't using real-time data, but it did provide everyone an understanding of, if we start progressing towards electrification, which is necessary in the city at scale to meet our 80 by 50 commitment, that's pretty clear at this point. There will be a time, in the next decade or so, where if we don't improve the electrical network, there could be major issues. And that kind of started coming out within that documentation in the next 10 to 15 years. So I would recommend, I'll share it in the chat. That's a really great resource to look at. And it's really different per area, so when we're talking about a project here in New York City versus what's going on in Boston or other municipalities that are thinking about building performance standards, it's a totally different situation. And like Beth mentioned, focus on resiliency of the grid in colder climates is also a huge topic ever since the Texas fiasco. So, we're constantly kind of trying to juggle that, but I think Richard's right. I mean, this is the direction we're going in, and so we shouldn't let that necessarily be a wall to hold back, at scale electrification.
Thank you. Vance, any issues? Any issues with your existing clients calling you up saying, hey, the building electrified next to me, I got no power?
Well, I was just on a project the other day where they are putting in heat pumps. I think it's a project you're working on, Richard, that the Sovereign with all those heat pumps, and they, as we were just reviewing the project, they didn't have the kind of electricity in the building yet to support this change to, heat pump chillers. And there was, I have no idea what their outlook is for the next 6 months to get that in place, because it seems there's a problem. A new building was built across the street, and they used all the power on the street. And I just wonder where that's going to go. I mean, I guess they'll support it, but I mean, will it be in a fashion that makes sense, or will they support it in a for new construction first, renovation construction later. Even when people look at local law 97 stuff, like Dave was just saying, and they say, oh, they'll work into the electric eventually, but how will you get it? I mean, they may make it part of their plan, but it may not be readily available. Will the infrastructure in the street right now support this new electrification process? If new construction goes the way it's going and electrification keeps going on its path, sure, it'll be worked out eventually, but will it delay older buildings getting the new power and only the new power going to the new buildings now? Or, is there going to be a guideline? Are we going to reduce watts per square foot on buildings to, hold them accountable? I mean, I don't know. I see, the pluses and minuses every time. And like I said, for the most part, 9 times out of 10, they work themselves out pretty quickly, but 10% of the projects are delayed.
I like this question because those are big delays. That is a huge concern if you're opening up a building or moving employees or transitioning in some way. So,
Scott, can I just bring up one real quick point, or 2 really quick points? I mean, there are parts of the city that have issue with electricity. We have to be very careful of that. But there are also parts of the city that have issues with gas. So natural gas isn't even just a great bet necessarily. And the other side of it is Texas doesn't use heat pumps. Texas, that's their biggest issue. Their electrical draw went up considerably. Mild climate, 1 in 100-year weather event, and just set up for the wrong equipment because they had no focus. Texas had no focus, and as many states, like even Florida to some end, on energy efficiency.
Is it also that they're being caught by climate shifting? A friend of mine from Arizona, from Flagstaff, sent me a picture just this weekend saying, hey, no golf, it's snowing. How's it by you? And I'm like, well, it's 55 here in New York. Maybe we should check if it's 75 in Alaska. I mean, it gets us back to, are these municipalities even thinking of climate shift? Right, we'll get that a little further. I want to hear what Beth Tomlinson, Paul Torsellini, and Matt have to say about, can the electric grid handle it? Beth.
So in addition to what I'd already shared, there was just the consideration of buildings not just being a user of electricity, but also being a partner in generation of electricity, or to the utilities in general. Some consideration around virtual power plants or power sharing or even microgridding. I mean, there are options out there to support decarbonization, and it doesn't necessarily have to demand that the utilities provide everything. So that was just one comment I wanted to add for consideration.
Okay. Paul?
So I've got a couple of thoughts on this. One is I heard an excellent presentation by a utility executive a couple of months ago. And her comment was, well, look at the history of electricity in this country. And in the 1940s, everybody wanted electric appliances and the utilities figured it out. And then in the 1970s, they had to double the electrical grid, which was kind of the number Beth used earlier, because everybody wanted air conditioning and they all wanted it today, and there was huge growth. And guess what? The utilities figured it out. And her comment was, we will make this happen. And so, that is, one viewpoint, and I'm not a utility expert per se, but I think it's also kind of going down to the building scale, and a lot of times this is a distribution issue, is that one way to look at it is we have twice as many power plants as we need on the fossil fuel side today, but they're there because of peak demand. And again, it goes back to my comments earlier that some of it is how you manage that and how you balance those loads. My all-electric house has very low demand. Why is that? My heat pumps are tiny. Part of that's efficiency, part of that's storage in terms of hot water. And as the end result is my heat pump never draws more than 1600 watts to heat my whole house and cool it, right? So that is a design piece of it and how you put those together. Where you get into troubles around peak demands and saying things like, well, we don't really believe in this heat pump, therefore we're gonna put in electric resistance backup everywhere. Well, that is problematic, right, from a design point of view. The other way to think about this is most of these buildings we're talking about have cooling capacities. And another mistake we're making is saying, we've got these cooling systems, and now we're going to, because we've got boilers we've got to get rid of, we're going to replace the boilers with heat pumps. No, the thinking needs to be is how do we take that chiller and use it to produce heat? You know, whether it's simultaneously, if you have both loads, or whether it's heat production and you're rejecting the cools. You know, you already have that electrical capacity there, right? That will take care of, in the New York environment, probably 70 to 80% of your heating load. And if you need peak demand, well, then it's a matter of, do you have electrical capacity, or do you stick with a little bit of gas, you know, around the edges there? The other thing that's happening is, you know, look at the lighting industry. You know, we've gone from 1.5+ watts a square foot on lighting, hopefully down to 0.4-ish because of LED lights. What are we doing with that 1 watt per square foot capacity? And how can that help us on the building scale? Right, so there's lots of things that I think we're forgetting in what does it mean to do this, right? On the one story about what NREL has done is on our parking garage, we've got a large scale PV system, and we've got several hundred EV charging stations. They actually have matched the load of the EV charging stations with the PV output, you know, based on what the charge level is, when people need to come and go, and they can balance those loads against that renewable resource we have without adversely affecting demand. Right, so that's just an example of, you know, a strategy that can be implemented. I think we can do this, and I think all the players can do this, you know, and it should not be a roadblock at the end of the day.
All right, Matthew, to finish off the question 5.
Yeah, well, I would like to draw some attention and amplify on what Beth was specifically referring to and some others, which is that the grid is not just a dumb grid that flows in one direction from a generator to a consuming site premises anymore. We have distributed generation. We have solar panels, we have wind, we even have on-site wind now. Maybe not so much in New York City, but I expect to see some. The centralization of the grid is probably going to be the biggest transformation of the grid to handle all of these things that we're doing, especially because we have been taking an all of the above approach to the energy crisis that is underlying our climate crisis. So one thing that I know has gone on for about 10 years in terms of projects to address decentralization in a planned architectural way, that is the grid architecture, other than just deploying solar panels and then now EVs, which have these batteries, which are an untapped, not only total capacity for storage, but distributed storage, is microgrids of various kinds that to date have typically been implemented for just a campus that's usually a single proprietor, but municipal microgrids were something that even NYSERDA was hosting a contest in about 8 years ago, awarding large grants for feasibility studies, et cetera. And I think that seeing the network of the grid and not just it as the means to the end of where that electricity comes into my premises, seeing that as a network, not just reflected in our bill with, you know, both the energy and the delivery as separate charges, but that network itself being independent of these big plants is something that is going to change and is going to really be a much more significant transformation than just increasing capacity and removing bottlenecks.
You went mute.
I show as, do you hear me?
All right, we're having some technical difficulties. As we can see, I have not put up question 6 up on the board. I've moved to question 8, my prerogative as the moderator. Does it make sense to electrify buildings if much of the electric power is produced from burning fossil fuels and natural gas? Obviously, some of that has been discussed, but In the bigger picture, are power plants moving faster to decarbonize than commercial buildings? You know, is it going to be a match? Charlie?
Well, I can't speak to
You muted?
power plants. That's a good question. Oh, no,
You're
can everyone
muted
hear me?
now.
No, I hear you.
I was able to hear Matthew and Charlie.
Yeah, I think it's you, Scott. Sorry.
Can't seem to hear. Can everybody hear me?
We can hear you, Scott.
Okay. Vance, would you like to answer that? Are any of your clients wondering why they should decarbonize when you know we're just getting coal-fired electric brought to our building?
Well, they're only looking at the local law 97.
We seem to have technical difficulties.
Oh, can you not hear me?
We
Scott?
can hear you. I think it's Scott has the issue.
Scott, you want to come off and then come back on again to see if you can get a better connection?
Oh, thank you, Paul.
It's me. I'm the problem.
Yes.
Can you hear me?
Perfect.
We can hear you.
Yeah.
Can you hear us?
I think others can go ahead and chime in on answers while he's working on his problem.
What the heck?
Yeah. Vance, would you mind if I answered that real quick?
Sure, go ahead.
Cool, thanks. So, we do see moving forward with electrification making sense prior to waiting for the entire grid to decarbonize. And partially related, if you live in a municipality that has an ordinance like Local Law 97, and there is now an increasing need to do that to avoid penalties, you should be considering that, and it's getting more aggressive. But it really relates back to the individual buildings, looking at if we can utilize the existing distribution systems, or if we're in like areas like Boston and New York City where you have steam distribution systems throughout the building itself, an electrification project might be really complex, costly, and have a lot of factors that relates to tenant turnover of the space. So, we're recommending in most applications like an incremental approach that starts to leverage the existing electrical capacity of that particular building, and then see what we could do with that. And then over time, perhaps add some additional means to take care of the rest of the heating load.
Well, doesn't that play into the heat pump aspect where you're basically switching from cooling only to heat pump equipment so that you could take advantage of getting the extra heat when you need it, and that same electrical connected load is used in ways then.
Right. Yeah, and using heat injection from something like the existing boiler plant or steam network might be necessary from the onset if you're going to go with that chiller heater approach, electrical means. But just kind of developing that more complex roadmap is usually required for these existing facilities.
Mm-hmm. Well, again, the 80-20 rule that they were discussing, that's a good plan. It works into the Local Law 97, the 40% reduction, and everybody's happy with that.
Don?
I would like to mention that one of the resources that the task force and ASHRAE is trying to pull together, or is pulling together, is we are doing a technical resource guide talking about the grid interactivity of buildings for decarbonization. This has been a major point of discussion within the task force. That guide is being produced and is scheduled to be out. It's being bid as we speak now, and that guide's scheduled to be completed in May of next year. So I guess the key is that ASHRAE is trying to address some of these issues, and stay tuned.
Mm-hmm. Great.
Everybody can hear me now?
Yes, we can.
Great. Let's go back to my question number 6. In a rush to decarbonize buildings, what is the one lesson that we are learning? I would like everyone to answer this. Let's start with alphabetical order. David Chen, please.
All right. I think the first thing is, well, first of all, hope you guys hear me. The first thing I think is like building operations and preventive maintenance. And I'll try to be very brief because I know there's like a lot here. I just think of like preventive maintenance and building operations is always neglected because we're always talking about the latest technology, the latest reversing chiller, all that stuff. But I think of like building operations and preventive maintenance as like fitness. It's 2023, new year, new me. You see a lot of people like at the gym, like working out, and like, but how many of those people like kind of like die off near the how many of those people make it to December? So you still got like maintain your diet and your workout to maintain that health and physique. It's the same thing for this. Good preventive maintenance and good building operating skills does help maintain your equipment for a long time. You're very efficient at its highest efficiency, and because you maintain a long time, you replace less chillers or less heat pumps throughout like a certain cycle. And because manufacturing all these high-end technologies makes a lot of carbon emissions.
Mm-hmm.
So overall, I just think preventive maintenance is a super key thing.
Don, what's the one lesson we should have learned by now?
Well, that's a tough question to ask in a 30-second must air. David had, I think, one of the key components. O&M is one of those major areas that we need to be looking at. Having the building operation be no more complex than what the operators can actually do. Training of our maintenance and operation folks is critical to us. Efficiencies, as we look at efficiency is one of those big components, but as we look in longer term, I think what we need to be thinking about is what is the embodied carbon in our facilities. As we get buildings more and more efficient, what happens is the embodied carbon becomes a much bigger component to it. So not forgetting embodied carbon is one of the lessons that we also need to be thinking about.
That's great. Richard?
I think the biggest lesson we have to learn is to stop rushing. When Tesla electrified a car, they didn't pull the engine out and put a motor in. They completely rethought the way a car was designed. It's the same thing for buildings. I think a lot of times we're looking at this as a fuel switch, basically as it relates to heating and cooling a building, or any kind of process within a building. And fundamentally, it really needs to be rethought and optimized around electrification. So I think a lot of people are just in a big rush to do it. It came fast. The early projects, really rolled out very fast, and there's a lot of lessons being learned, and that's a big part of it.
Right. Charlie?
So many lessons already, and probably a ton more to come. But I think if I had to summarize, Vance referenced a project I'm also familiar with the electrical infrastructure issue related to the utility industry. I think in the past year or so, we've learned electrical engineers are very used to this whole conversation, and usually, most of the people on this call have a mechanical engineering background, but leading really with the electrical perspective on what the existing infrastructure is, what is the capacity that we have. Just having a lot of these conversations first and thinking about the load letters very early in the when trying to request new service is super essential. And the other piece is, to Richard's point, there was an immediate practice of just throwing as many air source heat pumps on top of available rooftops. That was like one of the first things we saw, in addition to others recommending electric boilers everywhere. you know, and not really understanding it's probably going to be a suite of different solutions that maximize the COP, but also are really, you know, conscientious about the cost of the project. So definitely slowing down and trying to develop that complex, you know, roadmap really makes sense for the building. You're doing them a disservice if we're not, and you're just recommending just air source heat pumps everywhere without trying to think about how to try to utilize maybe that existing chiller plant with chiller heaters, something along those lines, how to maybe make some positive impact on the floor with new air distribution systems that can take advantage of the different coils, but also maybe there's another leveraging point to improve IAQ at the same time. You know, all these things have to be really considered when you're trying to pursue a decarbonization.
Thank you. Vance?
Well, you know, one of the biggest problems we've seen is, you know, that people don't look at the building from the envelope in. You know, the windows, insulation, ventilation, exhaust. You know, when they overview a system, you know, they skip that part and they go into the decarbonization. They think they're, you know, they're moving in the right direction, and they forget that if you take care of the envelope, you can reduce the overall load, and that's going to affect the building, and you're going to be more efficient all the way in. You know, so I think on our side, we like to see people, you know, do the easy stuff, do the envelope, do the low-hanging fruit, you know, VFD motors, drives, lighting, that kind of stuff, and then work your way into the building and get into the equipment.
Beth?
Hopefully you guys can hear me. In addition to all of the very thoughtful responses prior to me, I will reiterate that those suggestions were very valid. I would expand the conversation to the missing component of greenhouse gas accounting standards, which don't exist for the building industry to date, but are currently under development. So the lessons learned is that we are developing greenhouse gas accounting standards for the building industry to support performance standards like Local Law 97.
Thank you. Paul?
So I would avoid electric resistance. And
Excuse me?
I would avoid electric resistance as part of the solution. So I would really talk about kind of strategic electrification, you know, and we've talked about some of the other solutions there. But I am also seeing a lot of designs come in with electric resistance, you know, even as the primary heating source for these buildings. And, you know, that causes a whole set of problems, including the last question we had. And I guess I would like to reiterate what Vance was talking about, is that, you know, efficiency is the first part of this, you know, and it's an all-in efficiency routine to really make these systems work effectively.
Great. Matthew?
We are going to learn, whether some people notice it or not, that we started too late. And I mean that not just because of the damage from the climate crisis that is already being wreaked all over the place, some of it unseen, a lot of it baked into the pipeline, no matter how quickly we crank down greenhouse gases as we work on this and efficiency and everything else. But also we started too late because we'll see that because we have been missing the greatest investment opportunity in our modern civilization, and we haven't been reaping the benefits of that yet. And now, since we're rushing perhaps too much, we are getting those investment opportunities all over the place, hard and fast, and we are exploiting them. And not just because, you know, we will be avoiding the damage that comes from fixing this way of doing our civilization, but also because even just in the completely immediate sense, we are now finally providing a lot of subsidies. And so we are piling on top of the efficiency that saves energy and its inevitable cost, no matter how little we use, the investment in the value of our infrastructure, which, you know, as capital, that is a great thing to have in your property. a more valuable property that is also being subsidized broadly by society finally, and we will be doing more of that. And that is why we had people in this webinar telling us about incentives. And as one of the questions was, where are the other incentives? There are lots of them. And so while we are being driven to this finally, perhaps doing the right thing after we've exhausted all the other options, we are now arriving in something which is rewarding. And it is rewarding not just in the value of being able to, our civilization to survive, but in terms of actually making, by saving and perhaps even generating lots and lots of money. And I think that that is a lesson that we are all going to learn, although some will notice it more than others.
Okay, thank you, Matthew. As you can see, I've skipped to question 11A, which actually most of you panelists did not see. Matthew and I came up with that question on our own late at night. I don't know much about Local Law 84 or 87, but I heard it was the precursor to Local Law 97. So I was asked Matthew the other day, is it relevant anymore? Are they using it anymore? I've always figured, how can you design a building for energy efficiency if you don't know where you are, right? So Matthew, can you start us off? Then we'll go to Charlie on what's happening with 84 and 87. And if you could just spend 1 or 2 minutes just explaining what they are.
Take two, sorry. Local Law 84 and 87 were originally passed in 2009 by the New York City government as part of a package of laws that were back then called the Greener, Greater Buildings Program. And there are a couple of other laws that are not quite as relevant to what we're talking about today, but Local Law 84 is the benchmarking law, and Local Law 87 is the retrocommissioning law. Local Law 84 requires buildings over a certain size to report their annual energy and water consumption. That gets reported into an EPA database, but it's a New York City law with New York City violations if you don't comply. And Local Law 87, and the Local 84 is typically a data collection reporting exercise. It doesn't require anything on site necessarily or a professional engineer. But Local 87 for the largest of these buildings, because Local 84's thresholds have been cranked all the way down to 25,000 square feet, started originally at 50,000 and up. And actually right now there's an introduced law to lower that threshold down to 10,000 square feet, which will cover, I think, about 48 or 50,000 buildings total. But nevertheless, right now about 24,000 buildings are covered by Local 84, and Local 87 covers, I think, something like 12,000 to 15,000 buildings. Anyhow, 87, those buildings are required not only to do their 84 reporting annually, but once every 10 years, and each have a specific year they must comply, they have to have an on-site comprehensive energy audit, which we used to refer to as like an ASHRAE 2.5 level audit, even though there's no such thing. It's more than an ASHRAE level 2, less than an ASHRAE 3 audit. And that report must be prepared and submitted to the city by a licensed PE, usually a firm that goes on site and examines the operating equipment in the condition it is operating. So that means through the heating season, the cooling season, the shoulder seasons, and then makes a set of recommendations, some of which are mandated to be implemented, some of which are optional. But if you get a good firm to do it, all of which provide a tremendous ROI, because you now have recommendations that, though you were forced to get them, are beneficial, and sort of what I was mentioning earlier, in increasing your operating performance and so reducing your waste, which means not only reducing energy consumption that's wasteful, but also because all the systems are looked at and while they operate. I've seen the 87 reports find water leaks, which are not only wasting the energy that's in heated water, but also finding water undermining foundations and other structures, or attracting vermin, etc. So that's what 84 and 87 were. 84 is annual energy and water benchmarking. 87 is a once a decade retrocommissioning engineering report and recommendations. And they actually got a lot of New York City building owners and managers to finally do something about these problems in their buildings that they were able to ignore. And now they're in over a decade of compliance. They remain the foundation of New York City's climate mobilization, which it is now called under the Climate Mobilization Act that was passed, and 97 is a part of that. And indeed, Local 84 and 87 forms something of a pipeline through the new Local Law 97, which we've been referring to throughout this webinar. Is on everybody's minds because it, for the first time, sets fines for buildings emitting too much greenhouse pollution. 84 and 87 have been in effect for over a dozen years. They had a remarkable 75% compliance rate the first year. It was very rare for any New York City law. Actual 75% compliance. It's only increased even as the number of covered buildings has increased dramatically. Like as I mentioned, Local Law 133 that reduced the threshold of buildings for 84, not for 87, down to 25,000 square feet, and now it heads down to 10,000 if they pass the new one. The addition of Local Law 33 created grades from Local 84 percentile results, where you got a result for 84 that said, oh, you are better than this percentile of the buildings in the EPA database that are similar to yours by this fingerprinting process that seems to work pretty well. The New York City Local Law 33 has been requiring that each of these buildings that comply with 84 now must post their grades, and you may have seen them posted around New York City buildings, kind of like restaurant grades are posted, that show how those buildings do within these brackets that New York City has set up from these grades. And that requirement to post, as well as the combined Local 84 and Local 33 fines, which now total to $3,200 per building if you weren't to do either of those, right? That's made annual compliance business as usual for tens of thousands of buildings in New York City. And now Local 97 is, you could call it the end of this compliance pipeline, with fines for exceeding the building's emissions quota that benchmarking has been tracking every year. So Local 87 ties the Local Law 84 benchmarking and Local Law 97 fines for emissions, ties them together by requiring detailed retrocommissioning engineering project, as I mentioned, that reflects the previous year's Local 84 results, details recommendations that should improve emissions towards Local 87 compliance. That's why I call it a pipeline. Local 84's occupancy types are the basis for Local Law 97's types. And so the benchmarking scores and grades give indications and context for potential Local 97 violation. There are additional services available from firms in the city that target Local 97 compliance specifically. These services are not required to be engaged under Local 97, but they do direct improvements to emissions, ensuring the building is clean for Local 97 and not just in general for Local 84's benchmarking and not just for the older terms of Local 87's retrocommissioning, but targeting Local 97. So there are now, there are people who will do the benchmarking. My company, Blue Green Group, has been one of the top New York City benchmarkers by building count since the beginning, so we have a lot of experience in that. But there are also companies that, some of which were doing Local 87 compliance for that regime since the beginning, but now Local 97 is not once a decade like 87's retrocommissioning. Local 97 is an annual emissions fine for those buildings that violate their quota. And so there are firms that are now focusing on Local 97. Sometimes they do them in combination with 87 and 97, but it's 97 that is the end of the pipeline. So you don't have to wait for the once a decade Local 87 deadline, and it doesn't come with Local 87's broader requirements and a larger administrative overhead. They're focused on emissions, as we are focused on it in this webinar today. So that is a operations management process that there comes from having 84 and 87 still fully in effect, and 97. I think that Charlie might touch on some of this in 97, where he is much more expert than I am, at least so far. I'll be listening closely to what he has to tell us. But the 97 still has some things to be defined in terms of reporting standards, the reporting process and things like that. So keep doing your 84 and 87 reporting, and it will set you up well for Local 97 to avoid the violations, fines, and you know, keeping the greenhouse that's up against us.
Thank you, Matthew. Charlie, what are MEPs seeing with 84?
Yeah, I'll comment real quick, and I'll keep it short. I could also talk about this other question you have up on the screen, because they kind of tie together. You know, with Local Law 97 and those other laws, thanks Matt for the detailed breakdown. A realignment of all three laws is definitely being discussed with the Department of Buildings. The Local Law 97 Advisory Board report that came out at the end of December specifically talked just about this, and trying to understand if there should be a different cadence for Local Law 87, or if it should be amended for buildings maybe that are, you know, performing well under our building performance standard, Local Law 97, in comparison to this other ordinance. So a lot of thoughts given there. I would also say David Chen on the call here is also an expert of Local Law 87 in his previous life. But, you know, I think there is, you know, a lot of great information was identified there, not a lot of action. But now Local Law 97 is creating action even from a different focus point. And there are other cities leading to question 7, you know, Boston being the closest, I would say, with a finalized approach. There's other cities that are doing something similar now, which is great to see across the nation. Boston has BERDO 2.0, and BERDO 1.0 is essentially just their benchmarking ordinance, similar to Local Law 84. And now they're building upon that similarly to also move past just you know, an energy audit retrocommissioning kind of light requirement to having in place, you know, you have to, here's your cap, and you have to, you know, try to hit that, or else you're going to be fined. There's a lot of different caveats, really like the approach they took with BERDO 2.0, but it's very similar. So, you know, alignment of all of these laws across these different cities that are contemplating this is really essential moving forward.
Thank you, Charlie. Just for a moment, we only have about 5 minutes left. I'd like to take just a moment for a special thank you to Randy Top, VP Energy Service at Ainsworth, and Dave Lozak at BP Air Conditioning, K. William Bill Dean, who was a distinguished ASHRAE lecturer, and Erin McConaughey from Arup in California. They all helped with forming these questions and a lot of the answers that we've developed. In regards to what other groups are doing what around the country, Bill Dean had mentioned that Canada jurisdiction hasn't done much except with a carbon tax, that they had a lead position years ago in hydrogen fuel technology, but it didn't really pan out due to a number of challenges they were faced with. As this seminar really has focused on, it really starts with reducing loads. And that's where Canada kind of took a leadership role way back in 1980 with the rollout of R2000 that was focused really on that envelope with glazings and sealing, and there was really discussion about that envelope. So it was interesting to hear this group talk about that. Regarding what's happening in other cities, Beth, what do you see happening up near you? And next, Don, where you'll go afterwards, what's happening near you? And Paul, what's happening in your neck of the woods? Beth?
Yeah, so, you know, being part of a global firm, I see a lot happening across, you know, well, at least North America. So in Canada, I can say that their climate risk assessments help navigate potential impacts to decarbonization when they talk about embodied carbon. So ensuring that you're selecting materials that are appropriate for climate risk and risk mitigation, and, you know, reducing future embodied carbon requirements by deconstruction and rebuilding or reconstructing during, you know, after adverse events or natural disasters. So that's one consideration. But, you know, I'm also impressed by the city of Minneapolis's renter energy disclosure, which helps differentiate, you know, the renter market all the way down to 1 to 4 unit systems. So allowing the renter to see what the costs are for themselves so they can make informed decisions that help incentivize building, you know, building owners to improve their energy performance, and that helps support initiatives like Local Law 97.
Thank you, Beth. Real quickly, Don?
Well, I think in the interest of time, I think it's, rather than addressing what's in my territory, indication that there is a building performance standards technical resource guide that the task force is pulling together. It's now in publication, and so it should be out within the next month or so. And that is to provide technical support for building performance standards, both development and implementation. So I think that addresses your last question. Thank you.
Thank you, Don. Paul, let's finish this off.
Yeah, so I'll just say that there are certainly many cities around the U.S. and in Colorado included that are looking at moratoriums on natural gas and expansion of that resource. Also trying to make it easier to add more renewables to the grid, through policies as well. So it definitely, it definitely pops up around the country. The West Coast is very active also in this space. Several cities in California have done kind of the same in restricting the use of natural gas as an implementer to the decarbonization. So I'll leave it at that.
Thank you, Paul. All right, so we're all ready to wrap up. It's 11:59. I still want to thank all the panelists and the presenters for spending all your hours doing the homework and carving out the time we needed. I want to thank the audience. If you didn't get your questions answered, they will be looked at and reviewed. We will get answers back to you from the panelists, I promise you. We would also use those questions for our future events, which Matthew and I are already in development. We have a number of events we are going to develop, both with ASHRAE and other organizations. It's important that you use these QR codes or the link so that you can get your PDH credits for the 3 separate presentations. Will add up to 3.5 PDHs. ASHRAE New York will send all the registrants a thank you email along with the link for the access to the presentations and the video when it is ready for YouTube or wherever they're going to place it. And I just want to thank you again, Matthew, and I want to thank you again as hosts for attending this New York ASHRAE event. Thank you and have a great year.
Yes, thank you, everyone. These have been the fundamentals, and we look forward to seeing you and everybody you can tell about it when we do it again. We expect in April.
Great. Thank you all.
Thank you.
All right, take care. Thank you.